So let's do a bit of a review before we actually start Lesson 9. Let's start by drawing two perpendicular lines. Okay, and I'm going to make these approximately perpendicular. Or no, actually I could use my protractor to make them exactly perpendicular by lining it up with 90 here. Okay, and let us label this line M and this line L. Notice again we're using little script letters, which is the convention for labeling a line. Right in our arrows. Okay. Now, perpendicular lines, where they intersect, they create right angles. So actually, when these two perpendicular lines intersect, they're creating four right angles. This is a right angle. This is also a right angle. And so is this, and so is this. So when two perpendicular lines intersect, they create 1, 2, 3, 4. 4 right angles. Now let's remember what it means for angles to be complementary. Let's write the definition down here. Complementary angles add to 90 degrees. Okay, so complementary angles add up to 90 degrees. You need to remember that about complementary angle. So two angles are complementary if their sum of the measures add up to 90 degrees. So let's label some points. Let's call this A, B, C, and D. And let's call our origin, we'll call it point X. Now we can name some angles. Choose any point in the interior of BXC. So we're talking about this area here now. BXC is this angle. Let's choose a point Y. Any point in the interior. So let's say we have Y up there. And now draw the ray XY. Okay. I kind of wrote over my Y. Let me put Y underneath here. Okay, that happens sometimes. Now, let's call this angle 1 for shorthand and angle 2 for shorthand. So angle 1 is equal to what in terms of points? What's another name for angle 1? Well, angle 1 equals angle YXB. Okay, so we're just calling angle 1 a shorthand for angle YXB. Let's talk about here angle 2. What's another name for angle 2? Well, that would be CXY. Okay, so we could call angle 2 is the same thing as CXY. So we're just going to use the shorthands angle 1 and angle 2. Angle 1 and angle 2 are complementary. Okay, the sums of the measure of these two angles adds up to 90 degrees, adds up to a right angle. We can do the same thing in any of the quadrants that are created by these intersecting lines. So let's say we pick a point in the interior of angle BXA. Let's say we pick point Z over here. I can then draw a ray XZ and if I wanted to, I could label this angle 3 and this angle 4. We now have, again, that angle 3 and angle 4 are complementary because we have divided the 90 degrees that's in this quadrant into two angles. So we've got the fact that angle 3 plus angle 4 is equal to 90 degrees, or that angle 3 and angle 4 are complementary angles. Okay? We can do the same thing in another quadrant as well. So let's say we pick this quadrant, and we pick a point in the interior. Let's make it over there. And let's call this point H. Okay, I can draw XH. And now if I label this angle 5 and angle 6, yet again, I've got that angle 5 and angle 6 are complementary. Okay, and I can do it in this quarter as well. So realize that complementary angles add to 90 degrees and they add to right angles. Let's take a look at a straight line now. So let's draw a straight line. And on that straight line, let's put 3 collinear points. Let's call them A, B, and C. Oops. Okay, we'll call it A, C, and D. Okay, so we've got ourselves 3 collinear points A, C, and D. And now let's pick any point that's not on the line. We'll just make it above the line. And let's label that point E. Okay, now let's see first what we've done in terms of angle measures. ACD, these 3 collinear points, form a straight angle. So a straight angle has 180 degrees, which is the number of degrees in a line. So we could say angle ACD is a straight angle. Or we can also say that angle ACD, or the measure of angle ACD, is equal to 180 degrees. Okay. Now, if we drew the line CE, so from the middle collinear point, let's draw a ray or line CE. We've been mostly talking about rays, but lines also would create angles. Okay, but we're only going to look at the ray above the line. Then what we've done is now we've created 2 angles. We can call them angle 1 and angle 2. Well, what's another name for angle 1? Another name for angle 1 would be ACE. And what would be another name for angle 2? Well, another name for angle 2 could be DCE. Okay, angle DCE. But we're using angle 1 and angle 2 as shortcuts here. So originally angle ACD, well, still angle ACD is 180 degrees, but when we created these 2 new angles, we created 2 supplementary angles. The sum of the measure of angle 1 plus angle 2 is obviously also going to be equal to 180 degrees. So we can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Or we can also say that angle 1 and angle 2 are supplementary to each other, or we can just say they are supplementary angles. Okay, now let me go to another line. Let me make another line up. And let's say I pick 3 collinear points on this line, X, Y, and Z. And then let's say I take a point P that's below the line, over here. And now I pick the middle collinear point and draw ray YP. Let me call this angle 1 and this angle 2. The 2 new angles I created, let me call them 1 and 2. I'll sort of circle them so you could see them apart from the letters of the lines. And again, I've created 2 supplementary angles. Again, it's true that angle 1, the measure of angle 1, plus the measure of angle 2 is equal to 180 degrees, or that angle 1 and angle 2 are supplementary. Okay, so these are some ways in which we can divide 180 degrees into 2 angles which are supplementary. Let's look at a similar but related problem. Let's say we take a line And again, let's pick, in this case, we'll pick a point on the line. Let's go with A. And now let me pick several points that are not on the line. Let's say I pick a point B, I pick a point C, I pick a point D. And let me draw the rays AB, AC, and AD. Okay, and let's say I number these angles, number 1, number 2, number 3, and number 4. For reference, let me add a point G here and a point H over here. So what would be another name, let's say, for angle 1? Well, angle 1 would be the same thing as GAB. Okay, it's this angle here to there. What about angle 2? Angle 2, another name for it would be CAB. What would be another name for angle 3? That would be DAC. Another name for angle 4 could be HAD. Okay, and what is interesting about all these angles in terms of what their measures add up to? So what would be the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4? What do they add up to, all 4 of these combined? Well, angle 1 is from here to here. It would be that degree measure. Angle 2 from there to there. Angle 3 here to there. And angle 4 there to there. So put together, the angle measures of these 4 angles is this angle. And this angle is the same angle as angle GAH. So the sum of these 4 angles equals angle GAH, the measure of angle GAH. But what is the measure of angle GAH? Well, GAH is a straight angle. It's three collinear points on a straight line. So that means that 1, 2, and 3, and 4 add up to 180 degrees. So that's important that that makes sense and that you know what that means. And let's take a look, finally, at one more review topic, which are vertical angles. So the definition of vertical angles is a little technical, but what it's really saying is that when any 2 lines intersect, let's call this line L, and let's have another line that intersects line L. We'll call it line M. That when any 2 lines intersect like this, they create vertical angles. Okay, and in fact, when 2 lines intersect, they create 2 pairs of vertical angles. So let's take a look at one of the pairs of vertical angles. This angle here and this angle here, okay, which are sort of opposite of each other. Okay, they share the same vertex, but they're on opposite sides of the vertex. These 2 angles are vertical angles. And if we call this angle 1, we call this angle 2, then we could say that angle 1 and angle 2 are vertical angles. And therefore we know that the measure of angle 1 equals the measure of angle 2. Because any 2 vertical angles have equal measures. But it's also important to recognize that there is another pair of vertical angles that are formed by the intersection of these 2 lines. And I'm going to use a slightly different notation to indicate those 2 vertical angles. That's here and here. Okay, those are also, and I'm talking about the angle here and the angle here. So let me put some letters on these angles so that if it's not immediately clear, it will become clear. Let's call the center point X, and then let's label these points A, B, C, and D. So the first pair of vertical angles, angle 1 and angle 2, was the same thing as saying that the measure of angle BXA equals the measure of angle DXC. That's the same thing as this statement. So BXA and DXC. But now we've just drawn another pair of vertical angles. So our second pair, we can label these angle 3 and angle 4. So for the second pair, we're saying that angle 3, measure of angle 3, equals the measure of angle 4, and that angle 3 and angle 4 are vertical angles. Okay, and so it's really clear what we mean by angle 3 and angle 4. Angle 3 here is the same thing as BXD, and angle 4 is the same thing as AXC. And what we're saying then is that the measure of angle BXD is equal to the measure of angle AXC, which is the same thing as saying the measure of angle 3 is equal to the measure of angle 4. Okay, I hope this review may have clarified a couple of things about complementary, supplementary, and vertical angles.